Hi everyone, my name is Roman. I recently joined IG, and today I would like to present you one solution to dynamic JSON. We very much like strong type safety of Swift, but sometimes what we get from the server doesn't quite match our expectations. And in this case, there's one solution that we can use. Oops. So let's imagine we have typical response from the server. At the very top, we can have some header, which is usually the same after or in our responses. We might have some footer, which is always sometimes constant in a given endpoint. And in the middle, sometimes the server sends us just anything. Integer, error, status, string, can anything go there. And if you want to use Decodable, this can get tricky. So here on the right, we have a simplified structure where we can present this. So we have a static ID, which is the same for each response, and contents, which can be different, can be either an integer or let's say an array of integers. Now with this solution, what I'm thinking, we can have for this dynamic types, meaning the content can be strongly typed, and we can define later this type precisely inside as a structure in Swift without writing too much additional boilerplate code. Another potential use case where we may want to, let's say, delay loading or delay parsing or separate parsing of these contents is, imagine we have a mapping application. We have a route on map, and inside of this route, we have basic things like title and description, and also 10,000 GPS points and speeds of our vehicle and everything we want there, which will take a long to parse actually in real time. So this is, let's say, another type of content which can get tricky. Let's imagine another situation. We get from server a JSON which has a lot of data in it, and this data belongs to different domains. So for example, at the very top level, at the root level, we have, let's say, something that could be related to HTTP or something related to internal server status, let's say networking layer. Then a bit further, we can have something like description, titles, so let's say something general that we want to show the user straight away. And this is sort of different domain, let's say different screen that will be presented on. And even deeper, we can have additional data, additional details, which can also belong to some different domain. And what we would like really to have is to have all this separated, even though it comes from single JSON. So some way to actually separate parsing and handling of all those different layers without actually spilling all this information between all the frameworks that we are, for example, using, or all the layers. Thanks. Okay. So how we could usually approach it? That's, how about now? Okay. Okay, so let's imagine a typical decodable initializer at the bottom, at least the very front of it. So first, we just take the container, just keyed container, and we just grab the ID from it. Now, we want to delay parsing of the contents to some later time or another place. Because, for example, at this moment, we might not quite know what the type of the content is, meaning, for example, this framework might not have access to this particular type, or we might just want it to parse it at some future time. So the most, let's say, straightforward attempt would be to just store the decoder somewhere. Just store it somewhere and then try to use it later outside of this initializer. But there's one trick. The decoder that we see here, that's quite different from the JSON decoder, let's say, that we are using. And this object internally has state. So let's imagine that when we decode JSON from text, internally it creates something like we used in Objective-C, meaning a tree of dictionaries, arrays, and values. And internally, it contains all those dictionaries and arrays. And additionally, there's something similar to an, say, index path or key path. And this property stores where precisely we are at this moment in parsing. So for example, in this method, the current key path could be, for example, inside of this root structure. And probably the best way to describe this key path would be imagine a stack of dictionaries. And as we parse, dictionaries are added to the stack or popped from the stack. So when we are parsing ID and contents, let's say the root structure is the top of the stack. When we are inside of the initializer, let's say if you had an initializer for inside of the contents, which is second structure, and the top of the stack would be the contents structure. And when we have this decode for, let's say, for ID, and we give it this type of ID and key ID, it is only valid inside of this particular structure, inside of this particular place on stack. What would happen if we save this decoder somewhere else and continue parsing? It's internally mutable, or let's say the stack and the inside state would get mutated. So after this method finishes, after inside JSON decoder finishes, what we would have empty stack. And then if we try to, for example, ask this empty decoder with empty stack for a value of error, we would get runtime exception because there's no longer anything on the stack and just queries nothing. So there's one trick. It's not quite straightforward, but what we have this method for superDecoder, which is usually used for inheritance decodables. What it does internally inside of Swift, it actually creates another copy of decoder which contains the decoding stack at this precise moment in time. Let me find best words for it. Basically, this decoder that we'll get from this method will be inside of this content for me. So we have these 4 key contents. So the stack will contain additional contents inside of it, and it won't be used anywhere else. So since it's not used anywhere else, we can safely store it and use it at any time in the future, even after the JSON decoder finishes, it's allocated, and so on. And this is one basic trick to actually get something to decode after some time, after everything is finished for the basic decoding. So here we have this basic, let's say, wrapper for the generic REST response, which has a static ID and stores this content decoder. And we have also basic coding keys for the actual properties which will be there. And here we have another, let's say, specific response. So this specific response can be, let's say, something inside of another layer, not networking layer, but let's say some very specific domain layer like maps framework or something like this. And inside of it, we can precisely tell which type of object will be inside of the contents property. In this moment, at the bottom, there's an example. So the first line is how we just can create it on the networking, let's say, framework. And line below is how we would create this additional object from this generic response. And inside of the initializer, we can see that we can actually take this content decoder and just use it to decode whatever we want from it. Now, it gets interesting because, for example, we could take this example and, for example, make the contents lazy. Now, we will lose the exception throwing, meaning we would have to fatal error, something like this, or some other method, because the lazy properties won't allow us to throw anything. But then we can have something, a lazy property, if we really wanted to. Another, we can, for example, in the ID, imagine it was a string, which was the name of the type that we want to decode. Then we can have, let's say, entire hierarchy of objects where the type of the objects is not hard-coded in any of the structs, but it comes from this particular, let's say, ID or string. Another, which we can try if you want to do something asynchronously, when we create a specific response, we can do that anytime in the future, because the generic response owns the contents decoder. So even though after JSON decoder is deallocated, we can still use this content decoder to decode anything we want from it. And this is the basis from it. So to summarize, if you ever need something like to lazy load a JSON, meaning like load some parts of it at future time, or just split parsing to multiple objects, or if you don't know in your particular networking layer what type of the object will be, and you don't want to mix all those different domains together, this is one trick where you can use it. And this will be all. Thank you very much.